Hello all, welcome back to Sri Sai TechNique YouTube channel, Read Lead Success. I am dealing with the subject Network Analysis and Control Systems. I have already uploaded Module 1 to Module 4 videos, all the topics which are related to Module 1 to Module 4. If you have missed out, please do watch in my channel. And in Module 5, I completed all the topics. In this video, I am going to deal with the problems related to root locus technique. I've already completed all the topics under root locus technique, that is the first chapter of 5th module. In this video, I'm going to deal the problems which are related to this topic. First problem, consider the system with the following open loop transfer function. That is g of s into h of s, that is equals to k into s plus 3 into s plus 4. By s plus 1 into s plus 5 into s plus 6. So we want what? Root locus plot for this. How we can do, as it is an open loop transfer function, all the open loop poles and zeros are on the what? On the real axis. So the root locus will be symmetrical with respect to the real axis. As all the poles are on the real axis, it is symmetrical, as we have seen in the first rule. That there are three branches of the root locus equal to number of open loop poles. These root locus branches start at the open loop poles s is equals to minus 1, s is equals to minus 5 and s is equals to minus 6. If you see here, s plus 1, s plus 5, s plus 6. So s will be equals to minus 1, minus 5 and minus 6, where k equals to what? 0. As k is increasing, the root locus branches have the loop poles, open loop poles, and go to the open loop zeros. They leave from the open loop poles. From poles to zeros, they shift when k increases. Okay, two branches terminate on the two loop zeros. S is equals to minus 3. Terminate on the two open loop zeros. These upper one are zeros, as you know. Down one are poles. They move from poles to zeros. The zeros are minus 3 and minus 4. And the third one terminates on infinity. And the third one, that is minus 6, will terminate on infinity. The real axis segments between s is equals to minus 1, s is equals to minus 3, s is equals to minus 4, and s is equals to minus 5, and s is equals to minus 6. And s is equals to minus 8, minus infinity lie on the root locus shown by thick line. If you see here, it is clearly mentioned that these are poles, initial poles. So this is a 0. This is a pole. This is a pole. Okay. Now I'll mention with yellow color what are zeros. This is a 0. This is a 0. And this minus infinity is a 0. If you see, when k is 0, the poles will be here. Minus 1, minus 5 and minus 6. As k increases, the root locus branch leave the poles. The root locus branch, what will do? They leave these poles. As you can see this arrow mark, they leave the open loop poles and go toward the zeros. They move towards the zeros. This arrow mark shows that only. They move towards the zeros. And this, if this is a 0, which indicates which is going to 4. And 6 will go to what? To infinity. Like that, the root locus is plotted. Second question, draw a root locus for what? This transfer function. There are three open loop poles, that is s is equals to 0, s is equals to minus 1 and s is equals to minus 3. So there are three branches of root locus, same like previous how we have done. There are no finite open loop zeros. There are no zeros, as numerator doesn't contain any zeros. So all the three zeros are at what? Infinity, right? Therefore, there are three asymptotes. Asymptotes means what I told, no, that they don't cross over or they don't never touch, but they propagate to the infinity. So they are called asymptotes. As here all zeros are what they are like, they are going to infinity. As there are no zeros, it means they are going to infinity. So there are three asymptotes to respective poles. So the three branches of the root locus start at the open loop poles, that is s is equals to 0, s is equals to minus 1, s is equals to minus 3, where k equals to 0, and terminate at open loop zeros, where they terminate. Okay, they start at these poles and terminate at open loop zeros at infinity. As there are no zeros for they terminated k equals to infinity. So the three branches of the root locus go to the zeros at infinity along straight line asymptotes making an angle. As you remember in the rules, if you remember in the rules for asymptotes, we find some angle theta q. Theta q is equals to what? 2q plus 1 into pi by poles minus zeros. As poles is 3 and zeros is what? That is n minus m. If you remember, n minus m. If you have not watched the rules, please do watch. I have already uploaded the rules for construction of root locus. N minus m. N is what? Is the poles. Poles minus zeros. Poles is 3, zeros is as zeros there are no zeros. 3 minus 0. So Q will be what? 0, 1, 2. As there are 3 asymptotes. So 0, 1, 2. So theta naught is equals to pi by 3. Why? Because theta naught means what? Q 0. When Q you apply 0, what happens? Pi by 3 you will get. Nothing but degree is 60 degree. Then theta 1. When Q is 1, it will become 3 pi by 3, that is 180 degree. Then theta 3, when you substitute, this is not theta 3, it is theta 2. Why? Because 0, 1, 2 need to be substituted. 2 if you substitute, 2 into 2, 4, 4 plus 1, 5, 5 pi by 3. 5 pi by 3 means 5 into 180 by 3, 5 into 60, 300 degrees. So you got 3 angles, theta naught, theta 1, theta 2. 60, 180, 300 with the real axis. Then the point of intersection of asymptotes on the real axis called centroid. See, now we got the asymptotes. If you remember in the rules, once you find the asymptotes, what we find? We want the centroid where it is going to intersect. Okay, these asymptotes usually don't intersect, but you should know the centroid so that where the asymptotes are intersecting. So minus sigma is equals to, if you remember in the rules, there is something there is some equation called sum of real parts of the poles minus sum of real parts of zeros by number of poles minus number of zeros. If you know sum of real parts of the poles, real parts of the poles is what? 0, 1 and 3. As s is equals to 0, s is equals to minus 1, s is equals to minus 3. Then sum of real parts of zeros, there are no zeros, so 0 by 3. So number of poles is 3 minus 0. You get what? Minus 1.33 as the minus sigma value. That is nothing but centroid value. So the root locus exists on the real axis between s is equals to 0 to s is equals to minus 1. And from s is equals to minus 3 to minus infinity. So what it means? The root locus exists between what? 0 to minus 1 and from minus 3 to infinity. Why? Because here it is 0, 0 to minus 1, minus 3 to infinity. So the breakpoints are given by the solution of, as you know, breakpoints we have studied in the rules itself. The breakpoints are what? dk by ds is equals to 0. So we know that 1 plus g of s into h of s is equals to what? 0. So mod of g of s into h of s is what? 1. Right. So k by s into s plus 1 into s plus 3 equals to 1. If you substitute, then k will be what? S into s plus 1 into s plus 3. So if you multiply, you will get s cube plus 4s square plus 3s. If you do dk by ds, what you will get? 3s square plus 8s plus 3 equals to 0. So from this you can find the roots from this. How to get minus b plus or minus b plus or minus square root of b square minus 4ac by 2a. As it is the order of 2, easily you can find using this. Or you can use calculus also to do this, as it is a degree 2. So as minus b is 8, b is 8 and a is 3 and c is 3. Okay, if you substitute them in this formula, you will get what? Minus 0.451 as one root and minus 2.28 as another root. So one of these two breakpoints, these are nothing but breakpoints, not roots, breakpoints. Why? Because we're finding breakpoints, that is dk by ds is equals to 0. Sorry for that, I told as roots, it is breakpoints. Minus 0.451 and s is equals to minus 2.28. Breakpoint can be ignored as no root locus exists there. As you can see, we can ignore these two breakpoints. Why? Why? Because there are no roots existing there. See, minus 0.451, there is no root. Minus 2.228, there is no root existing there. So we can ignore that. Then it starts at s is equals to minus 3. If you see, it starts, this pole starts as minus 3, travels along the negative axis along the asymptote with 180 degree. Okay, this 180 degree and ends at s is equals to infinity. 180 degree infinity to infinity. Okay, the other two branches of the root locus start at s is equals to 0 when k equals to 0 and s is equals to minus 1 and move in what? In the opposite direction on the negative real axis, approaching each other, meeting at s is equals to minus 0.51. Minus 0.51, called the breakaway point. When you substitute this s place, that is in s place, if you substitute minus 0.51, you will get the k value as what? 0.631. See, we got two breakaway points. Now, if you substitute this minus 0.45 and this the main equation, you will get the k value as u of s into h of s equals to 1, you will get. No, if you substitute s place this 0.541, you will get 0.631 as the k value. So, they are approaching towards what? This is approaching towards this. Then call the breakaway point. Breakaway point from the real axis, enter the complex plane and then one branch moving to infinity along the 60 degree asymptote. See, first you should see the angles also. See, 180 degree, then 60 degree. Why? Because here if you see it is 60 degree from this point. From centroid we need to check that. You need to remember that. See, centroid, how much we got? We got as minus 1.33. If you see from this point, okay, from this point, if you take 180 degree, 180 degree, this is 180 degree. So it is moving this side. Okay, then if you see 300, it is going in this way. Okay, when it is 60 degree, it is going to shift here 60 degree. So 60 degree. So these two are moving towards, see what? 0.451 minus 0.451. Okay, call the breakaway point. Enter the complex plane and then one branch moves to infinity 60 degree asymptote and second one moves to infinity along the 300 degree, along the 300. See, one is 300 and one is 60. See, these are what? Asymptotes, as they are moving to what? Infinity. If they are moving to infinity, a curve is moving to infinity means asymptote. So the branches will represent the complex root known as complex root branches. From this 0.451 breakaway point, these asymptotes are drawn. And you can mention one more as what? These points meet at what? Minus root 3 and plus root 3. Even you can write that. Okay. Sketch the root locus of the open loop transfer function given g of s into h of s, that is equals to k by s into s plus 2 into s square plus 2 s plus 5. The open loop pole 0 configuration is shown in figure 6.8. Okay. From the rules described so far, the following information concerning the root locus plot is obtained. There are 4 open loop poles here. S is equals to 0, S is equals to minus 2, S is equals to, if you use Calcium find, you will get 2 poles, or else you can do different method also, factorization method also. If you can do any of the method, or you can do minus b plus or minus square root of b square minus 4ac by 2a. That formula you can take and substitute b as 2 and a as 1 and c as 5 like the previous one to find roots, and you will get what? Minus 1 plus j2 and minus 1 minus j2 respectively, where K is what? 0. Since there are no open loop 0, as you can see there are no zeros here. So all the 4 branches of the root locus terminate at what? Infinity. Same like previous, what we will do? We will find the theta q. Same like that, and you will put q0, q1, q2, q3. You will get 3 angles, that is pi by 4. Pi by 4 means what? 180 by 4, 45 degree. It is 45 degree. 3 pi by 4. 3 pi by 4 means 3 into 180 divided by 4. You will get 135 degree. 135 degree. And 5 pi by 4. 5 into 180 by 4. 5 into 180 by 4. You will get what? 225 degree. Okay. Then 7 pi by 4. 7 into 180 by 4. You will get 315 degree. 315 degree. So like this you will find. And n will be what? 4. 4 minus 0. Right. There are no zeros. N there are 4 poles. Okay. The point of intersection, again asymptotes, how you will find? 0 minus 2 minus 1 minus 1. All the poles by number of poles. There are no zeros, so minus 0 only. Minus 0. So what you will get? Lastly minus 1 at the point of intersection. The root locus exists on the real axis between s is equals to 0 to s is equals to minus 2. The root locus is existing on real axis between what? 0 and minus 2. Why? Because centroid is minus 1. Right. So the breakpoints are given by the solution of the equation dk by ds equals to 0. So you can write g of s into h of s is equals to g of s into h of s, that is equals to 1. You can write in terms of this. You can differentiate. After differentiation, what you will get? Minus 4s cube minus 4s cube plus 12s square plus 18s plus 10. Right. See, it is not 12s for 12s square plus 18s plus 10. Okay, you will get like this. After getting like this, here it is not square, it is cube. Okay, after this, what you can do? S plus 1 into s square plus 2s plus 2.5. 2.5 equals to 0 you can write. Right. How this is done? If you substitute s is equals to minus 1 in this equation, then you will get 0. So one of the factor will be what? S plus 1 will be one of the factor. Like this problems also I have done in the module 4, how to do to calculate a factor. See, if you substitute s place minus 1, s is equals to minus 1, then the equation becomes 0. Means s is equals to minus 1 is one of the factor, that is nothing but s plus 1. So when you divide this 4s cube plus 12s square by s plus 1, you will get the quotient, that is s square plus 2s plus 2.5. So when you multiply these two, what you will get? Again this only. So like this you will find is equals to 0. So s plus 1 into, again finding the roots for this by using formula or calculator, you will get these two roots or the breakaway points. Now we will finally sketch the root locus. Therefore the breakpoints are what? Minus 1 plus j 1.255 s plus minus 1 plus j 1.225. So all the three are valid breakpoints. All the three are what? Valid breakpoints. In the previous one only one is valid, other one is not valid. Here all three are valid breakpoints. So there is one real breakaway point and two complex breakaway points. One is what? Minus 1 is the breakaway point, minus 1, and other two are what? Complex breakaway points. Okay. What are the other 2 points here? Here these are the other 2 points, other 2 breakaway points. The complex root locus is shown in what? Figure 6.8. The remaining calculations are based on the rules to be discussed hereafter. This is not required. See here. See how it is written is s is equals to 0 first and s is equals to minus 2. It is between, you should draw between what? 0 and minus 2. It is, that is final. Why? Because the centroid you got is s is equals to minus 1. And you have, if you remember, you got what? 45 degree 1. You will draw here 1 and 135 and 135. Okay. 0, between 0 and 2 you have only 2, no, 45 and 135. When this is 45, okay, and here also you will draw downside 45 and here 135, here 135. So what happens? You can draw this as a curve from here to here. Okay, the points are what? Minus j 1.225 minus j 1.8. Okay, then minus, this is minus j 1.225, minus 1 into minus 1.225. This point will be minus 1 j plus j2 and minus 1 minus j2. Okay, and this is going to infinity, as these are what? Asymptotes. This is a centroid real break point. This is a centroid real break point. Okay, like this way we should sketch the root locus of the open loop transfer function. So this completes the root locus technique chapter of module 5, first chapter. In this we have already discussed all the concepts and even the problems related to the topic. In the next video I will start with the second chapter. Okay, from now I am stopping the video. Thank you. From Sri Sai Tech Edu YouTube channel. Read, lead, success. Keep reading.